Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Excuse me. Today's puzzle is called SVS number 464, Greater Than Killer by Richard. And here are the rules. We need to apply classic Sudoku rules, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have digits in cages may not be repeated. So that's typical killer cage Sudoku rules. And greater than signs between cages indicate which of the two sum totals is larger than the other. In case no greater than sign is placed between cages, the cage sums may relate to each other in every possible way. So you could have any combination of situations when the cages do not have a greater than sign between them. Otherwise, for example, this cage must sum to a sum greater than this cage's sum, which must sum to a sum that's greater than this cage's sum, etc., all the way down. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. We have a nice little situation here. So these cages must add up to 45. This cage is 2 digits, which are greater than the sum of these digits, which must be greater than the sum of these digits. And they all add up to 45. So 2 digits greater than... So these 2 digits can either be up to 17. 5 digits is at least 15, so therefore this must be 16 or 17 to add up to be greater than this sum here. So we have this is either this is 16, which would mean this is 7 and 9, which means it's greater than 15 here, 1 through 5, which means this has to be 14 here. Or this could be 16 here at most, because this has to be 17 at least. So we could have 1, 2, 3, 4, 5, 6. And this is guaranteed to have a 9. So this could be 6 and 7 in that case, if that were the case. Or 5 and 7 in that case, if this is 1, 2, 3, 4, 6. So we're guaranteed 1 through 4 has to be in this cage here. It's either 1, 2, 3, 4, 5 or 1, 2, 3, 4, 6. But we have a 2-cell cage which must be greater than this one. So therefore this must be 16 here. Because 2 digits can be at most 17. So this has to be 8 and 9 here to add up to 17, which is greater than 16, which must be greater than 15, which must be greater than 14. Because of the way that these equalities run and the way that they sum up together. Well, this is greater than that, so this is at least 18. So 17 plus 18 plus 19 is possible. To add up to 18 without 8 and 9, because of the 8-9 pair in the box, it can only be 5, 6, and 7. So this has to be 5, 6, and 7 here. That's 18. This must be 1, 2, 3, 4 then, guaranteed. That's 19, and therefore the 9 has to be here. Because 1, 2, 3, 4 plus 9 is 19, which is greater than 18, which is what 5, 6, 7 adds up to, which is greater than 17, etc., etc. So 9 here means this has to be 8, which makes that 9. That eliminates 9 here, so it's 7 and 9 there. 8 eliminates 8 here, so it's 6 and 8. So those are the possibilities. These cannot be 5 because of the 5, 6, 7 triplets in the row. These two are at most, again, 17. So that means this has to be at least, sorry, at most 16. Okay. What other situation do we want? Let's see. We have this is greater than this, which is greater. Okay, so how does this work? So this is going to be smallest. Yeah, we're going to have to use that many. Smallest, second smallest, third smallest, fourth, fifth, sixth, seventh, and eighth. And this cannot be 8 and 9. So this is 13 at most. So 13, 12, 11. So this is guaranteed to be 13 at most here. 13 plus 12 plus 11 is 36. And 45, which is the digits from 1 through 9, minus 36 is 9. So if any of these are smaller, this can't be a single digit. So this has to be 9, and this must be 13, 12, and 11 here. That makes this 10. This is less than 10. So it could be 9, 8, 7, and 6. So this has to be 6 and 7. That eliminates 6, 7 in the rest of the column. So this is 5. No 5 here, no 1 here. So again, 13, 12, 11, 10. Remaining digits of column 4 are 1 through 4. This can't be 1 because of 1 in the box, so this must be 1 here. So 13, this is 12. It cannot contain 6, 7, or 9, and it has a 1. So it has to be 1, 3, 8. Because 1, 2, 9 was eliminated. 1, 4, 7 is eliminated, and 1, 5, 6 is eliminated. So this is 1, 3, 8, which leaves the remaining digits as 2, 4, and 5 to add up to 11. 3 and 8 eliminate 3 and 8 in the rest of the column. This is less than 10, so this can be at most. This is less than 9 at least. So this has to be up to 6. So we don't have 1, 2, 3, 4 available in the rest of this middle box, box 5. So that's 5 through 9. No 8 here, no 9 here. 9 cannot be either of these because these must be less than 10. So, and this can't be 7. So where is the 9? The 9 has to be here because there's no other place for it in the central box. We have 5, 6, 7 as a triplet, which eliminates 5, 6, and 7 in the rest of the column. So this is guaranteed to have a 5 here. This cannot be 5 then. We have a guaranteed 8 there. This is at most 9, at most 8, at most 7. So this is 1 through 5 there. This is at most 6, so 1 through 5 there. Okay. This is greater than 11, so this must be at least 12. So it has to be 4 through 8 here, because it can't have a 9. This is greater than that, so this is... So we have at least 12, at least 13, and at least 14 here. So if this is at least 14, it has to contain an 8, because we don't have 9 available because of 9 in the row. So this can't be 8, it's 3, which makes that 8. This can't be 8, so it can't be 4 and 8 here. So this is either going to be, so this is at least 12, at least 13, at least 14. So it's at least 6 and 8. It could be 7 or 8 here. So this cannot be a 6-7 pair, because if it were 6 and 7, that would eliminate all possibilities for this cage here. So this must be 5 with 6 or 7. And it can't be 5 and 6 because that's not 11, which is not greater than 11 here. So this has to be 5 and 7, which eliminates 7 in the rest of the box. So this is 6, 8 as a pair. So this is 14 adding up. This is 12. Therefore, this must be 13. That means this cannot be 6, 5, 8 or 6, 7. It's 4, 9, which leaves the remaining digits in the boxes 1, 2, and 3. 1 and 3 eliminate 1 and 3 here, so that's 2, which leaves a 1, 3 pair remaining in the box. Remaining digits of row 3 are 4, 5, and 7. These two digits must be greater than this, the sum of digit. So if we don't have a 7 here, that means if we don't have a 7, these would be 4 and 5, which only adds up to 9, which would have to be greater than the sum of these digits, which would be at least 7, 1, and 2, which adds up to 10. So we have to have a 7 in this cage. So this has to be 7 here, which means this can't be 7 there. This again cannot add up to 10. We have to have 6, 7, or 8 here. So this could be up to 3 here. 1, 2, or 3. Okay. Remaining digits of box 1, we have 1, 2, 3, 6, 8, 9. So no 8 here. No 9 here. No 6 or 8 here. Okay. So 9 has to be in the cages here. We don't know which, though. This adds up to 12 at most. So if that were the case, then this would be 4 plus 2 other digits to add up to 11 at most. So 11 minus 4 is 7. And 2 digits trying to add up to 7 at most would be 1 through 6, but we can't have a 6 because of 6 in the column. Well, where is 7 in column 1? Can't be here because of the way that the cage has to be smaller than this. Can't be here because of 7 in the box. Can't be here because of 7 in the box. So 7 has to be here, which eliminates 7 here. Okay. We have a 1, 2, 3, 4, 5 quintuplet in box 4, which eliminates 1, 2, 3, 4, 5 in the rest of the box. So we have 6, 8, and 9 remaining. 6 and 9 can't be here because of 9 in the column. So 9 has to be here, which leaves the remaining digits in this box as 6 and 8. That 6, 8 pair eliminates 6 and 8 in the rest of the column. So where is 8 in box 1? Can't be here because of 8 in the row. Can't be here because of 6, 8 pair in the column. Can't be here because of 8 in the column. So 8 has to be here. Well, where is 6 in this column? Or in this box? Can't be here. Again, can't be here. So it must be here. Well, 9 then has to be one of these two digits. If 9 is here, that's 15. But 3 and 8 is not going to be greater than 15. So that cannot be here, so 9 has to be here. So 9 eliminates 9 here, so that's 4, which makes that 9. 4 eliminates 4 here, so it's 2, which eliminates 2 here. So this is a 1, 4 pair, which eliminates 1, 4 in the rest of the box. So this is 2, 3 is a pair there. This can't be 2. 4 eliminates 4 here, so it's 5 and 4. 5 eliminates 5 here, so it's 7 and 5. 7 eliminates 7 here, so it's 6 and 7. 2 eliminates 2 here. Okay. Where we have 8 and 9s left. So we know where the last 9 is. It's there. Okay, so these add up to 36 total. Remaining digits of row 9 are 1, 2, 3, 4, and 8, with a guaranteed 8 in one of these 3 cells. This cannot be 6 and 7. Where are 6 and 7 in box 9? They have to be here. And 6 and 7 plus the minimum, which is 1 and 2, adds up to 16. So this has to be 1, 2, 6, and 7 here. And that eliminates 1 and 2 in the rest of the box. So this is 3, 4, 8 as a triplet, which eliminates 3, 4 in the rest of the row. And that leaves this as a 5. And this is 16 here, guaranteed. So this must add up to greater than 16, which makes that 8 and 9, adding up to 17. 8 eliminates 8 here, so it's 6. This can't be 6, it's 5. This can't be 5 or 6, it's 7. 6 and 7 eliminates 6 and 7 here, so that's 8. 8 and 1 has to be less than 10, and that is. 7 and 2 must be less than 10. So therefore, this must be 2 and 7, because 3 and 7 add up to 10. Therefore, this can't be 2. This is 3, 4 as a pair. 1 and 2 eliminate 1 and 2 here. 8 eliminates 8 here, so it's 6 and 8. 1, 2, 3 eliminate 1, 2, and 3 here. This can't be 3. This 8 eliminates 8 here, so it's 4. That eliminates 4 in the rest of the box. So that leaves this as 6 or 7 remaining in column 9, but this can't be 7 because of 7 in the row. So this is 6, which makes this 7. That eliminates 7 in the rest of the box. This can't be 1 because of 1 in the column. 1 and 5 eliminate 1 and 5 in row 5. So we have a 2, 3, 4 triplet, which eliminates 2, 3, 4 in the rest of the row. So this can't be 2, 3, or 4. It's 7. And 2 is guaranteed to be one of these two digits, which means this cannot be 2. This again adds up to, this is at most 8. This is at most 7. So 5 can't be here because 5 and 3 at minimum adds up to 8. Remaining digits of row 4 are 3, 4, and 5. No 5 here because of 5 in the column. No 4 here because of 4 in the column. Remaining digits here are 2, 3, 4, 5. And one of them is a 2. No 5 here. No 4 here. Okay. Can we have a non-2 here? The answer is no. If we don't have a 2 here, this means it's 3, 4, 5 at minimum, which is 12, which is not going to be less than 12 here. So we have to have a 2 here, which means this can't be 2 here. No 2 there. 2 eliminates 2 here, so that's 1, which makes that 2. 1 eliminates 1 here, so it's 3, which makes this 1, which makes that 2. 1 eliminates 1 here, so it's 3 and 1. And this can't be 3, so this is 2, 4, and 5, which adds up to 11. And that must be less than 7 and 5, adding up to 12. So this is 5, which makes that 4, which makes that 5 there. No more 5 in this box. Where is the 5? In row 6, then. Can't be here because this must add up to 7 at most. This can't be here because of 5 in the box, so 5 has to be here, which makes this 3, which makes that 4. That leaves that as 2. 2 eliminates 2 here, so it's 6. 6 eliminates 6 here, so it's 8 and 6. 8 eliminates 8 here, so it's 3 and 8. No more 1 and 2 here. No more 5 here. 6 eliminates 6 here, so it's 7 and 6. 6 eliminates 6 here. We have 1 and 2. 5 eliminates 5 here. 1 eliminates 1 here. This is guaranteed to be a 3-4 pair then. That means this can't be 3 or 4. It's 1. We have a 3-4 pair here, so this can't be 3 or 4. It's 5. This 3 or 4 pair adds up to 7. That means this must be less than this. And that, yeah, I can't have 9 here because this is 9 here. So this is 3, which makes that 4, which makes that 3. Which makes that 4. 4 eliminates 4 here, so it's 3, which eliminates 3 here, so it's 2 and 3. 2 eliminates 2 here, so it's 1 and 2. 3 eliminates 3 here, so it's 4, which eliminates 4 here. So that's 1 and 4. And that's the solution. Yep, fairly straightforward. I've done a lot of Killer Cage Sudoku, so this was easy for me. But, yeah, I don't know. I'm not sure how to grade this, because This was very easy for me, but it might not be very easy for people not used to Killer Cage Sudokus. I don't know. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.